Hello guys, this is Rupesh and you are watching CP Peanuts video series on binary tree interview questions, and this is about printing the top view of a binary tree. So this is your binary tree here and this is your eye. I have tried my best. Okay, so this is your eye. You're looking from here. So if this is the tree, then you would be printing this, and this, because from top you can only see this. You cannot see this 8, this 6 and this 1. Okay, you cannot see these 3 because they are covered by these upper nodes. Okay, and there can be another, maybe this is 9 and maybe this is 1, and now if you have maybe 12, so you would say, now what, can I see 9? No, because it is actually covered with 5. Can I see 10? No, it is covered with 1, but you can see 12. Okay, so to understand this better, it is always good to draw a line. So we'll start drawing lines. If you will just start from the root, it will be helpful. So this is your one line, another line which is covering 3 and 8, and then 5 and 9, 8 and 1, and then this 12. Okay, similarly 4 and 1 are covered in one line, 7 is covered in another line, and in 4 is covered in another line. So now you consider which node is coming first in this line. We can see those nodes. Okay, so 2 is coming first, 3, 5, 8 and then 12, but 1 is coming second in this line, right? So we cannot see 1. Similarly 9, 8, we cannot see all this because they are covered. So this is the problem. And if you'll ask, can I see, maybe if this is maybe 1, then can I see this 1? No, you cannot, because this 1 is actually coming below 2. Okay, so this is the node which is covering 1. So in order to understand this better, there is a trick. And the trick is you start with the distance. So you consider this root. So as this is root, you have a 0 distance. And when you go left hand side, you make 1 minus. So this is -1, this is -2, this is -3, and this is -4. Similarly, if you go right hand side this distance, you will make 1, 2, and 3. So now it's easier to tell you that at -4 distance, or the leftmost distance, we will print 12. So for -4, you will print 12. So like this, you will start printing. So the question is print top view of a binary tree, right? So you'll end up printing 12 and then 8, 5, 3, 2, 4, 7, and 4. And the indexes are like -4, -3, -2, -1, 0, 1, 2, and 3. So this is the key. This is going to be the value. And if you will take map in C++, you can store this as a key and this as a value. Okay. And wait a minute. People would try to actually solve this problem using recursion, but then you will need some extra logic. It's not just simple traversal and printing whoever is coming first or hitting first. No, like that it won't work. For example, you are applying left order traversal. Okay, then in that case you will hit this one first, and then you will go for this one, this one, this one. Then there is nothing, you will try to come back, but now you are going here. So the moment you are hitting here, you know that okay, this is line number -1, and I already have a value for -1, meaning I will discard this. Okay, because this is coming under this distance or line, whatever you call it. So we'll not make 8 as the value for this -1 key. Okay, and then we'll go further. Now we'll hit this 9 here because we are in left order traversal, but we'll see that this 9 is under -2, but we already have hit -2 with 5, so we'll not make this also, and similarly this one. But the moment you will reach here, you will find out that -4 was still empty, so you will assign this 12 as a value to this key. Fine? Yeah, till this it is okay. But now assume you are done with this whole thing, right? So this much is done, right? So then you will go back from here to here. Now you will reach to this 3 again, right? So you are reaching 3. You will try to go to this one, 6. Okay. Now you are at 6. What you will feel? Okay, 6 is coming in the line 0. Okay. So you will see that, okay, 0 is already have value 2 because we started from here, right? So we'll start making the entries. So the moment you will hit here, you will create a map key with value 2. The moment you will go here, you will create a map key -1 with value 3. And obviously you will check whether that key already exists or not. If it already exists, you will not create. But I'm trying to explain that it won't work if you're using recursion. So why it won't work? Let's see. Let's suppose you have one more data here. Let's say 10. So you will come here. Now, as you have reached here, you cannot go left. You will try to go to right. So as this is line number 0, this is going to be coming under line number 1, this 10. And 1 is still not assigned. Now, what you will do, you will assign this 1 with 10, not 4. Okay. Now here it is wrong. You should have 4 here. So you can still do with the recursion by looking at the levels of these nodes. So see, this 10 is at level maybe 3, but this 4 is at second level. So you will know that, okay, I have the value 10 inside my map, but that 10 is with level 3. But now I have hit another node for the same key, which is 1. But now this 4 is having 2 level, meaning it is actually above 10. So the chances of 2 being seen from top are more. So you will actually replace this 10 with 4 if you are keeping the track of the levels also. But then that is extra logic and extra value in the stack. But still, if you want to do that, go ahead. But there is another approach. We'll use queue and another data structure, which is going to be your map. Okay. So this is going to hold two things. One is your node. So the data type would be like this for this. So we have this node pointer and the distance. So this is 0, -1, -2 and all this. So let's call this distance. So node pointer comma distance. So this is going to get stored here. So as a start, you got this 2 here, right? So you got 2 as a node and distance is 0. So this is the first entry in the queue. And then you will loop over this queue till this is empty. Until this is empty. So we have started while loop. You have this first element in your queue and we will check, is this queue empty? No, it is not. Then we will take out this one. So we'll just cross this. For now, I'll just do this and try to see this 0 is the distance. Is this 0 available in this map? No. Then we'll make this entry and we'll make this 0 as a key and 2, which is going to be either you can store root, the node pointer, or you can just store the value of that. So 2 is associated with 0 now in the map. Cool. And then in this loop, you will check what are the left and right for 2. So you will hit 3, which is with -1 and 4, which is with +1, right? So now we'll process 3 with -1. We'll take out this and process. And we'll see -1 exists in this map. No, it doesn't. Then we'll create this with 3 as a value. And once we are done with that, we'll see 3 is having any left or right. Yes, it is. Then 5 and 6 will also come here. So 5 with -2 and 6 with 0, because this is coming under this line. Okay. So I'll tell you how we will do that. Actually, it is very easy. The moment you are going from your current node to left node, then you just have to decrement the value. And if you're going to the right, you just have to increment that variable value by 1. That's it. Okay. So this is your queue now, and I'll process this again. And obviously this 1 is not there, and we'll make this entry and then we'll try to find 4. This 4 is having any left or right. So for now, just assume that this 1 is not there. So yeah, 7 is there. So we'll make that 7 also here, and then we'll process 5. So minus 2 is also not there, correct, with 5. And similarly, we'll check for 5. So we have 2 8, this 8 and this 8. So for simplicity, I'll make this one as 80. So we have 8 with minus 3 and then 80 with minus 1. Okay, good, right? Then we'll process 6, 0. But wait a minute, the 0 is already existing in the map. We'll just simply discard this. And sorry, this 7 is with 2, okay? So my bad, you guys must be shouting if you was paying attention. Yeah, so this 7 is with 2. We'll discard 6 and then we'll go check this one. We'll remove this one and try to process this. 2 is not there inside this map, right? So we'll make this entry 2 with 7, okay? This map is getting bigger. And yeah, after going further, you will check 7 is having any left or right. Yes, it has. So I'll start just from here, 1. But this 1 is coming with line 1. So we'll just put it like this. And this 4 is coming in line 3. Okay. So 4 is coming in line 3. And then you will process 8 with minus 3. You will see minus 3 is not there. You will make this entry with 8. And then 8 is not having anything, so we'll not push anything inside this queue. So now let's look at this 80. 80 we will remove and see, does it have anything? No. For now, you just forget about these things. These are extra. You know that, okay, down the line it will actually hit this 12 with this 4. So for now, assume that this is not there. I was just keeping this for the example. So 80 is not having anything in the left and right, but 80 is with distance minus 1. Okay, so minus 1 already exists, so we will just simply discard this one also. We'll go for this 1 and 1, which is this guy. We'll see 1 is already there inside this map, so we'll just simply discard this also. We'll go for this guy. 3 is not there in map. We will make this 3 with value 4. So you have successfully traversed your whole tree with complexity of n, and your space complexity is going to be like the width of the tree. So you can consider that as m. Okay, so pretty good complexities, and you have this as output. And yeah, and so the correct order would be minus 3, minus 2, minus 1, and then 0, 1, 2, and 3. So if you are storing this in a map, if you are using C++, then in that case, it is already sorted. You can just simply loop over it. And it's time to look at the code. We have this node as a root. We'll just simply see if it is empty or null pointer or null. We'll just simply return from here. If it is not, then we will create map with integer and integer, queue with pair, which will help you to combine two different variables. So the data type is node pointer and integer. Remember, I was doing this. We were having this node pointer and the key. So similarly, we will have data type node pointer and integer as a pair in the queue. And we are going to push this root with distance 0, okay, inside this queue. And we'll iterate over this whole queue and your job would be done. So we know that there is single value inside this queue. We'll take out that value using front and we'll remove that value from that, take out this node and the distance from that pair. So this is actually pair what you got from here. This is exactly this one what you inserted here. And now you will check if map, you will try to find the distance or the key. If it exists, if it is equal to null, and meaning it is not there in the map, then only you will make that entry inside this. Otherwise, you won't do anything. Just go ahead with the flow. You will try to see this node's left is not equal to null pointer. Then you will try to push that also into the queue. And if you will find node's right is also not equal to null pointer, then you will push that right with distance plus here, see, and with distance minus here. So for now, as distance is 0, so this is going to be minus 1 and this is going to be plus 1. Okay, so now Q was inserted with 2, 0, and then we just popped this out, so it was removed, and Q was empty till this line, but then you again pushed roots left which is some value, maybe 3 with -1. Okay, so again this queue is not empty, and then you will loop over this queue, and then it will be storing everything into this map, and then you can iterate over this map and print this element's second value, which is going to be the node's value. So you will get your desired result. I hope I was clear enough. Thanks for watching, guys. Bye bye, take care. We'll see you in the next videos.